Hello guys, in this video I'm going to show you how to simulate simple logic circuit and logic gates in general in LabVIEW. So again, LabVIEW comes, any new project in LabVIEW comes with two panels, the front panel that you see here on the left, and the block diagram panel in which you're going to implement the actual circuit. So we have in this tutorial basically the tutorial draft here. So we're just gonna follow the steps in that draft. Okay. So first we're gonna create a project. We already created. Now we're gonna save the project. So file, save as, and we're gonna save it as tutorial number 3. Okay. So in step 5 here, it says in the Project Explorer window, right-click my computer and select new VI. VI will open just these two panels again, which is already opened for us. Okay. But anyways, if you want to do it, to find the first is the Project Explorer panel or window, which is this one here. I believe you can do it from window maybe. Or yeah, when here. Yeah, maybe show project. Yes, show project. Okay. And basically you right click on my computer. If you select new VI here, it will open again another window for like block diagram window and the front panel window, which was already opened for us. So we don't need that. Okay, that's good. So let's continue here. So here is basically the circuit that we're gonna implement. Okay, it's a truth table. You know, any logic circuit can be represented at the end of the day as a truth table. So that's basically the truth table for that circuit. Okay, you have 4 inputs, and this is the output Z. And later in our course, we're gonna learn how to basically from a truth table extract oh, I'm sorry, extract the logic function, as an algebra, like an equation for the output. Okay, which we have in here. Okay, so we're gonna skip this step and just go with what we have here. Okay. Then okay, number 7 here. Okay, we will need 2 switches configured to provide inputs to the circuit. Right click the front panel of the VI and find vertical toggle switches under Boolean in the control panel. So here is the control here, this one. And it needs right click front panel. Okay, that's basically the front panel. We right click on it. Okay, we just open another one. So we need what? We need, yeah, this one here. And we need vertical toggle switch. And you need 2 of them. So that's number 1. And that's number 2. Okay, and whenever you create something here in the front panel, it will be reflected in the block diagram panel, The front panel is basically, your the front panel, the front end. You don't see the physics behind. Here you implement the circuit itself in the block diagram panel. Okay. Okay, so place 4. So we need 4, not 2. So let's correct that. We will need 4 switches, not 2, as I expected. That's an error. Well, let's open it again. So we need 4. So we have 2 already. Number 3 and number 4. Okay. Okay, place the 4 vertical toggle switches in the front panel and label them DCBA. So let's do that. D, B, C, A. Let's also try to increase their size, or at least you can increase their size of, okay. Just click one of them. Yes. Okay, it's a little bit tricky, but you know, you try to select one and you're gonna see like prompts or locations to. Okay, if it didn't work, you can just copy and paste the ones that you already. Let's do that here, copy and paste. Yes. And you can paste again and again. Okay, we're gonna name this guy D, this guy C, then B, and finally we have A. I believe also you can resize or change the font from here. Font dialog, choose a size here like 24, for example, and make it bold and click OK. Okay, good. So we have the 4 toggle switches. Okay, vertical toggle switches. Okay. Now we need a LED on the front panel as an indicator, you know, to show the output. High means 1, or basically if it's on, if it's lighting, this is high. If it's not lighting, you know, if it's off, this is 0. So how to put that? Again from the controls maybe, yeah. Here is a round LED. Let's check what he did. Move over block diagram and we will okay, so it is the same here. Okay, and let's call it Z. Let's also change the font to 24 and make it bold. And increase the size a little bit. Okay, good. Okay, now move over the block diagram, which is in here. We will need 4 inverters for each input. Right click on the block diagram and node gates are under Boolean. Okay. So here is the right click. It will show you this function window. I believe this is Boolean here. And we need 4 inverters. This is the inverter. You can copy and paste it 4 times. Okay, I have 4 now. Okay, it says in step 10, connect the, connect basically these inverters to the inputs that we have. So let's first change. I believe this guy should be D, not. Maybe it's here called D. Yeah, it's D. Okay, so we have the D. We're gonna connect an inverter to this input. That's good. We have Mr. C. We connect with an inverter as well. Okay, so we did this. Okay, to implement 4 input AND gate, we will need to get the compound arithmetic symbol. So the AND gates in the Boolean window here, like this one, I'm sorry, the AND, like this one, for example, or the OR gate, you know, these are 2 input. It's not 3 or 4 or whatever. No. So, I mean, let's do that. Let's put like an AND gate and see. So here is an AND gate. You see, guys, on the left, it is just 2 green bubbles. These 2 green bubbles shows like it can accept only 2 inputs, not 4. If we look at our Boolean algebra equation here, it has 4 input. So we need an AND. We need to AND these 4 inputs together. These 4 terms. So we need an AND gate which accept 4 inputs. And for that, we're gonna use this guy called compound arithmetic. Okay. So we'll not use the AND gate. So again, right click and this guy here. It comes by default, as you see guys on the left, like 2 orange bubbles. Okay, so again it accepts by default 2 inputs, so we need to increase that. So we just yeah, when the arrow looks like that, you can now extend, so can do whatever, like 100 input now. So we just need 4, and here is 4. Okay, now we need the logic. We need to change, because this compound arithmetic can be anything, so we need to make it like AND. So right click on it, I believe you choose the mode and make it AND. It's by default OR, and we need from that 4 of them, because we have like 4 terms. Okay, this is basically what we did, choosing the logic as AND. Then we just do the basically the logic circuit. Okay, so we're gonna start by the first term here. The first term is D dash or D complement, C complement, B complement, A complement. Okay, I'm sorry, A is not complement. So the A is the only one that is not complement. So we need D complement. We need C complement. Let's put this on a side here. That's D complement. Now C complement. Now B complement. Then A, we need A. We don't need A complement. So we take that from A. Okay. That looks good. Let's make this wider a little bit. Okay, second term here, D complement, C, B complement. So everything is complement except C. So we take D complement first. We can just extend this line here. So it will, yeah. Then C will not be complement. So C, we're gonna take from the input itself. Then D complement, we can take from that line. Hopefully it will work. And we need A complement, not A. Okay, good. Looks good. Looks good. Okay. So D complement C, B complement, A complement. Now the third term. Oh. So yeah, third term is D complement C, B complement, A. So D and B are complements, C and A are not complement. So D and B are complements. So let's do D and B first. D and B both are complements. C and A are not complement. This is A here. So yes, it is A. It looks bad. So okay. Then C is not complement as well. Good. Final term. D, C complement, B complement, A complement. So everything is complement except D. So let's start by D. I'm gonna take D itself. Then everything else is complement. So we're gonna need C complement, which is that guy here. D, then B complement as well. Then A complement. That's good. Okay. Then after that, we need to OR the four terms together. Okay. So I believe without looking at the manual, I believe he added another compound arithmetic for the OR. Let's just keep track of him. Yes. So add a compound arithmetic and configure it to be OR for input or gate, and connect the output to the basically this indicator here. So right click, Boolean, another compound arithmetic, over to show this arrow, double edge arrow, and extend it to be 4. Right click, choose a change mode and make it OR. It's OR by default, as we said. So we just connect the outputs to the inputs of that basically 4 input OR gate now. And the output should be connected to the indicator. Nice. Okay. So we connected everything now. Of course, we might have errors, by the way. It's okay. We might, I'm not sure. But we're going to know from the truth table when we run this circuit, we're going to know if the output follows the truth table on and off, then we are good. Okay, then save VI as Tutorial 3. We already did that, so we just need to make saves like that. Okay, click the run continuously button. This is basically in the block diagram panel, which is one here, I believe. So the continuous run, there are 2 buttons, one in the front panel, this one, and one in the block diagram. You can press any of them. Then you can run through the entire sequence to verify the output of the. Let's see. We're gonna do one by one. So gonna go here. Okay. 0, 0, 0, 0. We should have zeros. So let's see. Don't need that guy now. Okay. Yeah. 0, 0. Every 0 is basically means the switch is low. The switch is, to the bottom. So everything is 0. Now 0, 0, 0, 1. So everything is 0 except A will be 1. We have 1. Correct. Then 0, 0, 1, 0. So everything is 0 except B. And we should get 0. That's good. Fourth case, 0, 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. We should get 0. Then the fifth case, 0, 1, 0, 0. 0, 1, 0, 0. And let's see, 0, 1, 0. Should we get 1? Correct. Sixth case, 0, 1, 0, 1. 0, 1, 0, 1. And for that, we should get 1. Seventh case, 0, 1, 1, 0. 0, 1, 1, 0. And for that, we should get 0. That's correct. Then 0, 1, 1, 1. 0, 1, 1, 1. And we should get 0. Then the ninth case, we have 1, 0, 0, 0. 1, 0, 0, 0. And for that one, oops, we have a mistake. Okay, for this one, 1, 0, 0, 0, we should get 1. We have here 0. So we have a mistake somewhere. We have a mistake somewhere. Okay. So let's now search for this error. Okay, good. Okay, so to debug that, you should know which term will be 1 in that case, okay? In the 1000 case, okay? Which should be 1, but we have 0. So let's see, 100. So we go to the function, okay? So if D1, then D bar is 0, so that term will be 0, that term will be 0, that term will be 0. Remember, we need 100. So D is 1, C bar 0 complement will be 1, B bar 0 complement will be 1, A bar 0 complement will be 1. So it will be 1 or ANDed by 1, ANDed by 1, ANDed by 1. Okay, 4 ones. So that term should be 1. So the error in the fourth term, which is D, C bar, B bar, A. Let's see, which is this one here. This this compound arithmetic or AND gate here. So first, let's check the let's stop the simulation. Let's stop the simulation here. So we first change the mode. The mode is AND, which is good. Okay, that's D. That's good. We need then C bar. That looks like C bar. It's not bad. That's B bar. That's, oh yeah. You see the error, guys? It's D, C bar, B bar, A bar. We connect here A. So that guy is wrong. That wire here is wrong. We should connect it to A bar. That's good. That's very good. Very good exercise. Okay, let's run again. Let's go from the beginning. Okay, so first 0, 0, 0, 0, we have 0. Then 0, 0, 0, 1, we have 1, that's correct. Then we have 0, 1, 0, that we have 0, that's correct. 0, 0, 0, 1, 1, correct. Then 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1. Then 0, 1, 0, 1, 0, 1, 0, 1, that's also 1. Then we have 0, 1, 1, 0, 0, 1, 1, 0, that's 0. Then 0, 3 ones, that's also 0. Then 1, 3 zeros. 1, 3, 0. This is the problem that we have. And it's now 1. We're correct. Now 1, 0, 0, 1. 1, 0, 0, 1. That should be, the rest should be zeros. Okay, all the rest. Okay, 1, 0, 1, 0. 1, 0, 1, 0, 0. Okay, good, good. 1, 0, 1, 1. 1, 0, 1, 1. Also 0. 1, 1, 0, 0, 1, 1, 0, 0. That's good. Then 1, 1, 0, 1. 1, 1, 0, 1. 0, good. 3 ones, zeros. 3 ones and the 0. Again, 0. Then 4 ones, 0. So we could implement it. Okay, that's the correct way to implement it. Okay, guys, that was it for tutorial 3. What you should submit is basically like a screenshot of each case of each of these. So 16 screenshots. Like, for example, the first screenshot should be 4 zeros. 4 zeros. That's a screenshot, this part. Second screenshot should be 0, 0, 0, 1. 0, 0, 0, 1. Second screenshot, and shows that this is lighting, and so on. Okay, guys, thank you very much for watching, and see you in another video. Bye-bye.